Kelly here from Radix Labs. Since two of my passions are cookies and production scale manufacturing scheduling and optimization, I'm going to demo using Radix's Slipstream scheduler to over-optimize baking many cookies. We typically use this scheduler to optimize real-time resource utilization in life science laboratories. First, a bit about how I've defined this protocol. I've used blocking resource groups because they don't let any other tasks be scheduled on a given resource or resources until all tasks in that group have been completed. They can be useful for when you want to ensure that a collection of tasks happen on the same piece of equipment. For cooking, this makes the scheduler minimize cleanup. Now, about this protocol. Because all baking is better at industrial scale, we'll be making 10 batches of cookies. I can set this just by setting the loop variable here. I could use this to make one batch, or many more batches, but 10 batches seems like a completely reasonable number to me. 250 cookies shouldn't take too long to eat. First, we have our tasks which require a mixer, then the tasks that require a bowl, and then finally, the tasks that require a tray. Now, these tasks can use more than one resource as well, as we see with baking the cookies, which requires both a tray and an oven. If either of these resources aren't used, we'll either have cookies that aren't cooked, not the best, or a fire in the oven, even less optimal. For the resources available, for now, I'm assuming a relatively standard home kitchen. One bowl, one cook, one sink, one mixer, one tray, and one oven. Okay, so let's click Schedule. Right away, you can see that it scheduled our protocol remarkably quickly, in about a second. You'll also notice that I didn't have to spend an hour manually packing tasks onto resources in a hacked-together Excel spreadsheet. We can see that the tasks which are resource constrained on multiple resources, for example, mixing ingredients here, which requires both a bowl and a mixer, have been scheduled correctly at the same time using both resources. We can also have Slipstream compute and visualize the critical path for us. Here, the tasks which are surrounded in orange and highlighted are on the critical path. This is simply the longest path through a process. In other words, if we want to finish baking sooner, these are the tasks that it would make sense to try to shorten and that we want to make start as soon as possible. Okay, so now that we've had a bit of a look at what the schedule looks like, let's go ahead and try to optimize some of our resource utilization. So, just for the sake of argument, let's try increasing the number of ovens that we have to 2 and the available trays to 3 and see if that improves our schedule. Okay, so from the results here, we can see that extra ovens don't actually help all that much. The second oven isn't very well utilized, and additionally, only one of the tasks is actually on the critical path. Since ovens are relatively expensive and time-consuming to install, investing in an extra oven wouldn't actually help us make cookies much faster, so therefore that probably isn't something that we want to consider. This is especially useful in the life sciences, where liquid handlers and mass spectrometers make ovens look cheap and simple to install. Now, taking a look at increasing our number of trays, we can see pretty confidently that increasing the number of trays does actually help. This helps us keep the ovens in use, and this is because the trays have to let the cookies cool on them, and we also have to wash the tray, which requires additional time beyond the time that they are in the oven. And importantly, as we see here, more trays can be utilized efficiently, since front-loading tasks onto extra available trays can keep the ovens baking more of the time. Okay, so this was a relatively reasonable baking session, but what if we want to scale up even more? Okay, well, let's try to scale up to making 50 batches of cookies. Now, since I'm not really into 24-hour baking marathons, let's increase the number of resources to match. So let's use 5 bowls, 2 people baking, 1 sink, 5 mixers, 20 trays, and 1 oven. All right, now let's submit this to the scheduler. Okay, so you'll already notice that this did take a bit longer to schedule. However, importantly, I didn't have to rewrite the recipe or spend a few hours manually scheduling tasks by hand. I'm also still utilizing my resources efficiently, as you can see in the resulting schedule. It also only took me a few seconds to manage scaling up production by 5x. Now, this scheduler can be used for holiday meal planning, making massive amounts of food to store, or managing hybrid and variable workflows in the wet lab. Just maybe don't eat the results from the lab. Reach out to us at hello@radix.bio if your lab wants to bake industrial scale cookies, or just want to utilize your resources more efficiently.